So we'll start now the problem. You have all the proofs with you, the Cardinal's method.
Sir, we are getting 3 roots for this, for delta less than 0. So then which root should be neglected?
That you know.
The middle root.
Middle root, yes, same rule, same thing will apply. You know the feasibility, right? Yeah. Maximum volume is for gas, minimum volume is for liquid. In between you have to neglect. Very easy, right? Okay. So what's the first step for this problem? Your equation is z cube plus alpha z square plus beta z plus gamma equals to 0, right? We have to calculate. So an alpha, beta, gamma, it is given in terms of AB, capital AB, UV, right? So, and I am asking you to do by Van-der-Waals equation of state. Very straightforward. So, capital A is AP by RT whole square. Okay? What is the answer? You have to write the units. If you don't write the units, you may get wrong results, because now that you are lucky that your units are compatible, the units are not compatible, you get wrong results. How much is your A, capital A? And then you do capital B, which is BP by RT. A is AP by RT whole square and capital B is BP by RT. How much is coming capital A? How much is coming capital A? Pardon? If you talk in terms of 64.3813 into 10 to the power minus 3, capital B is always write in terms of this better, you know. But you can anyway, whatever you can comfortable with, you can always go for. You can always go for that. Yes, quick. 0.01. 14.32 into 10 to the power 3246. 10 to the power minus 3, correct? Alpha, which is, how much should be for this case? Alpha equals to, for Van-der-Waals, the table is with you. Minus 1. How much it is, alpha? Minus 1.0143. Beta equals to, beta equals to, am I correct?
Yes.
Beta equals to A means 64.3813 minus 3. Gamma is minus AB. How much it is coming? Minus 9.224. Now everything is over. We will go for P. This equation will transform to x cube plus px plus q equals to 0. P is how much? You know the P, right? You have done it. P you have done, right? What is P? What is P? Beta minus alpha square by 3. How much you are getting? P is you are getting beta minus alpha square by 3. How much you are getting? What is that? Minus 0.2786. And Q, which is 2 alpha cube by 27 minus alpha beta by 3 plus gamma. How much it is? How much it is coming? Q equals to minus 0.0564 and delta equals to 2 square by 4 plus P cube by 27. Q square by 4 by P cube by 27. How much is coming? Minus 5.66 to the minus 6, right? It is less than 0. 3 solutions. It is less than 0. 3 solutions. So you have the formula. This depends on this R and T. So next step is to calculate R and cos theta. Next step is to calculate R and cos theta. Next is to calculate R, which is already given the formula. So how much you will be getting? The formula from formula minus P cube by 27 whole to the power half. How much is coming? R. It should not be a complex number. Be careful while putting the minus sign within the root. How much it is coming? 0.0283. Now this is very crucial, but we have to get cos theta and then theta finally, because if you have cos theta of no use, because you need to evaluate this. Theta by 3, theta plus 2 by 3, and then theta. This is the catch here. Radian and degree, you know that in calculator. If you do the mistake, entire calculation will go wrong. First this step, cos theta. How much? Cos theta is how much? How much is cos theta? 1. No. That is a very crude approximation. It is not 1. You know that if you slightly part of 1, theta will have a great perturbation. Cos theta equals to? Don't say 1. If you say 1, that's it. Your theta equal to 0 means doesn't make sense. Pardon? 0.996 is very correct answer. 0.9965. And how much is it? How much in degree? Theta? Cos theta you got 0.9965. And pardon? 4.7. Roughly you can say 4.8 degree. No problem. That approximation is okay. 4.8 degree. Now, see, so easy this technique. That's why I wanted this part to be included in the exam. Why you will go iteration? You have done it now. Last step. Z1, Z2, Z3. You are done it. Over. Why to have so much iteration? That's a very crude way. You can do that way also, but this is the more formal way. No tension. You have the formula. Plug it in. Get the answer. Answer Z1, Z2, Z3. Z1, Z2, Z3. Z1, Z2, Z3. You have alpha everything also there. Alpha is already there, minus 1.0143. It's already there. Z1, Z2 and Z3. Yes, time is up. So much of you should get me the answer quick. Z1, Z2, Z3. Yes, you get Z1, Z2, Z3. It's so straightforward. It's nothing is there actually. Just put in the calculator. Theta is already given. It's so straightforward. First one is how much? Who said 0.9474? That's the right answer. 0.9474. Z2? 0.0187. 0.0187. Z3? 0.0482. Somebody got, who got it? Yes, 0.0482. Now you can see which is the lowest, which is the highest. The lowest, this is the highest, intermediate, you can discard, and from there you can get, from here you can get Bg, from here you can get Bf, and Bg is what? Z equals to Pv by Rt, and this Z Rt by P. So Z1, it should be Z2 Rt by P. Put the values, we get the answer. Job is done. Is this easier method? Yes or no? So up to this is the syllabus. Up to this, not beyond that. Okay? So I think your headache is gone, so you can directly solve this kind of problem, liquid, vapor, everything with the analytical method. So I think this part is complete, is quite understandable. Next we will go to the, so if you look at A and B, they are the function of critical temperature, critical point, TC, right? So this, any equation of state, if you look at, it is P equals to RT by B minus B minus A by B minus B whole square, or B square plus UBV plus WB square. This A and B, once we have to calculate. Generally I am giving in the class these values. But these values are the function of the critical point at TC. Okay? How to calculate A and B? How to calculate? So now we will be discussing. So generally we give that people measure experimentally, but you can calculate mathematically A and B for equation of state. So let's look at that part and calculate A and B and show for the van der Waals. You can go back home and try to do for SRK and paying the Wilson equation of state. So let's look at the VDUS, which is P equals to RT by B minus B minus A by B square. Simplest form. That's I will say my equation number A. This I will say my equation number A. At critical point, remember that this A is the function of critical point, B is also the function of TC. In the Payne Robinson and SRK, this will be multiplied by alpha 1t, ATC by alpha 1t. Alpha 1 is a function of M1, is the eccentric factor, and so on. I have discussed in the class, and this will be a bit complicated for the SRK and the Payne Robinson equation also. At critical point, if you look at your diagram, this is so here this goes like this. This goes like this, and you can see this narrowed down, and this is the point where, so this, let me draw in a proper way. This is the critical point, and here it goes like this. So after that, where ideal gas close condition equations will be valid. So this is called point of inflection at the critical point. This is called point of inflection. A critical point. This is called point of inflection. At this point, dou P by dou V at Tc and dou 2P by dou V square at Tc can be written something. What is that? At that point, dou P by dou V is positive or negative? Is it positive or negative? Zero. Zero. That's right. Both are zero. So that's very interesting thing. You are getting the solution and you are finding some place it is, some solution is giving that. That means you are at the point of inflection. You are at the point of inflection. You are at the point of inflection. That this is the pressure, corresponding pressure, and you can see that your entire thing has mass to one point. Entire thing mass to one point. Okay? Now, you have to apply this to calculate A and B. You have to get A and B. So at critical point, P equals to PC, B equals to BC, T equals to TC. At critical point also, PC equals to RTC by BC minus B minus A by BC square. Equation number B. You can also write this as PC plus AC A by BC square into BC minus B equals to RTC. Whatever way, both the equations are accepted. From equation A, if you look at equation A, dou P by dou V at Tc equals to 0. If you apply to that equation of A, this equation, what actually happens? What will you get? Dou P by dou V at Tc equals to 0. If you apply, what will you get? What form? I want the form. Very simple. Very simple form you get from here. What form you will be getting? Dou P by dou V at Tc. Dou P by dou V at Tc. Minus RTC minus divided by BC minus B whole square plus 2A by BC cube equals to 0. Equation number C. Next we will employ dou 2P by dou V square at Tc. This is also equals to 0. And from the same equation number A, we can get 2 RTC by BC minus B whole cube minus 6A by BC to the power 4 equals to 0. Equation number B. The consequence of equation number C. If you take the derivative part of the equation number C, you can get equation number D. Now you divide equation C by D. You divide equation C by D. Divide equation C by D. Dividing C by D. What we do get? Dividing C by D. What we do get? Dividing C by D. What we do get? What we do get? Dividing C by D. What we do get? Very simple you will get. Very simple. If you divide C by D, BC equals to? No. Very simple form you get. Now what? You get critical volume. You will get critical volume from here. What is that? Yeah, that's what. That's what I'm saying. Very simple thing you get. BC equals to 3V. Now look at equation number C. What you got? RTC by BC minus B whole square equals to 2A by BC cube. You now incorporate BC equal to 3V here. You get TC. What will you get TC? So I will say this is my equation number A1. Previous one, BC equals to 3V. I am saying equation number A1. I am saying this is my equation number A1. How much you will get TC? From here you get TC.
Sir, 8A by 27 R.
BR. 8A by 27 BR. Equation number A2. Now look at equation number B. This equation you can take. Now we have to calculate PC from this equation number B. If you take equation number B, which is PC, you can take this one also known for RTC by BC minus B. TC is known, BC is known, BC is known. You can get PC from equation number B. What you are getting PC? So equation B will give you now PC, which is equals to which equals to A by 27 A by 27 B square. Equation number A3, sorry, not C. Now I promised you to get A and B, the van der Waals constant A and B, in terms of critical temperature, pressure and volume, right? In general we do it in terms of critical temperature and pressure. So what are the values of A and B? That's what I am asking for. First you can get value of B. If you divide A2 by A3, you can get the value of B, because A and A will get cancelled. If you divide A2 by A3, A and A will get cancelled, you get B. And what is the value of B? What's the value of B? What's the value of B? What? Any idea? It's very quick, man. You can do it quickly. It's not that difficult. It's not that difficult.
B by R?
8?
B by R?
No, it is not that simple. It is simple, but B equals to RTC by 8 PC. A equals to, now equation A3 you take. Equation A3 you can, if you take the simplest equation, because you can plug it, the B value, plug the B value, you get the value of A. Remember that A and B value should be obtained in terms of R, TC and PC. No other terms should be there. Because A and B, that the function of the critical point and critical point any substance, we know critical point pressure and temperature at least. Volume is difficult to get, but critical point pressure and temperature is known. Critical point pressure and temperature known, and in that case, if we tell you, okay, this substance critical pressure and temperature, this you can calculate the A and B, the Van der Waals gas constants, other cases, other parameters.
27 R square
27 R square by 64 PC. Now your task is you go back home. Can you calculate A and B for SRK and Peng-Robinson? If I wanted to calculate A and B for SRK and Peng-Robinson, can you do it? If you want to calculate for the Peng-Robinson A and B, can you calculate? What will be the form of your A and B? Will that be same? Will that be RTC by PC or something else will be there? Or will that be for A value? Will it be same or something else will be there? There is nothing but R square TC2 by PC, but something else will be there. What is that? How much is 27 by 64? And how much is 1 by 8? How much is 1 by 8 this fraction? 0.125, right? Yes, am I correct?
Yes, sir.
And that A fraction 27 by 64?
0.121.
Yeah, these numbers, how that will be changing if you have other equation of state? That means how this will change if you use SRK and Peng-Robinson. How my ATC and BTC will be? How my ATC and BTC will be? Can you do it by the same procedure? Can you do it by the same procedure? What we started, for example, you take the SRK, for example. You take SRK, uniform is ATC alpha 1T. And this term is different, something like B square plus UBB plus BW square, all are there. You have this equation, we will have this kind of equation, we apply dou P, we have the same set, C, D, A1, A2, A3, and you get the answer. Okay. I was thinking also this problem to give in the quiz 1, but you are saying no. Okay. This derivation I was thinking for SRK for the quiz 1. So you are saying no, so I am not giving in the quiz 1. Otherwise I was thinking this problem. Okay. So, but since you are saying no, I will not give this problem. These are one of the possible problems for quiz 1. Yes?
Very good.
Huh? No, but the thing is that I have to go by the class. The class says no, I cannot include it because class is very important to me. You are also important to me, but thing is not you are the only person. If you say yes, I will go for SRK. For this one, that's it. SRK or PR. I will say a question. Find out ATC, BTC for SRK or PR. That's it. Somebody will do SRK, somebody will do PR. Not Van der Waals. Van der Waals have done the class. That's your choice, not my choice. Next I will go to corresponding state. Laws of corresponding state I don't like, but I have to teach. And of course, no questions I give, at least for the quiz for the corresponding state, only comes in the end semester. So corresponding state generally, so far I have not given the quiz, but I have to teach the syllabus. So we will start now. Law of corresponding state. What is law of corresponding state? Any idea? See, when we write Van der Waals equation of state, which is P plus A by B square into V minus B equals to what? Okay? And if you look at your diagram, PV diagram, change from material to material. If I say water ice, one diagram. If I say some other solution, some sodium chloride solution, some other diagram, some other organic liquid, some other diagram. Can I have only one diagram which will be valid for any material? That means I have to express in terms of dimensionless form. That means I have to express, for example, we talk about Reynolds number in fluid mechanics. We say Reynolds number 1800, right, for laminar, or 1900, I don't know exactly. Something like that, right? Something, we don't remember actually. That's our order. And that is valid for any material. If I say water is flowing, salt water is flowing, or some petrol also flowing, no problem. The Reynolds number says, okay, what is Reynolds number? Which is LV rho by mu. Whatever, the channel. Sometimes I will say I have a big channel, big leg or whatever. I don't, this is actually dV rho by mu, which talks of the cross section, diameter. So I have a big diameter, I have a small diameter, I have petrol, I have water, whatever the case, everything is included there. This number is a parameter. This number says that the flow is laminar or turbulent, depending on this, all this material property. But if I don't know the material property, I know only this variable or this number for Reynolds number. This does not take any material, it is invariant. It is a material invariant. It is material invariant. Similarly, can we have material invariant property? Material invariant property such that we can get material invariant equation of state, and that's called laws of corresponding states. What is the reduced pressure and temperature? Pc. Okay. That means what we are doing, the philosophy of this, why we do that, this everything is having some unit. So this has no unit, dimensionless. We have to make it dimensionless. We have to make this dimensionless, and automatically it will be that, so that we can get something called material invariant properties, and which thermodynamics people say laws of corresponding states. So we have dimensionless pressure, dimensionless temperature. So, and we will be doing by Pc, P by PR. This is a reduced pressure, reduced temperature. Okay? And we have A and B given. So what will be your equation in the Van der Waals equation of state in terms of reduced temperature and pressure? So if I write P plus A is 27 R square Tc cube by 64 is Tc cube or Tc square? Just take it out. Tc square. Tc square 64 Pc by B square, B minus RTc by 8 Pc equals to R. Correct? Yes? Instead of P, you can write PRPC 27 R square Pc square by 64 Pc V square, B minus RTc by VR Vc minus RTc 8 Pc equals to R PRPC. This is my equation number A1, equation number A2. Objective is to write in terms of PR, and TC and all should not be there. When you have the final equation of state, remember that final equation of state should not have a material property. If TC is coming in the final equation of state, that means your corresponding state or material invariant equation of state is wrong. So can you please derive it out? Your equation of state Van der Waals in terms of PR and VR. Divide PC by BC. Divide PC and PC by BC. Both sides of equation B. Divide PC by BC. If I divide PC by BC, what will actually happen? I divide PC by BC, both sides means I divide this side by PC, this by BC, this will be my PC BC. Right? Divide by PC BC. If I divide, what will happen? PR plus 27 R square PC square by 64 PC square VR square BC square into VR minus RTC by 8 PC BC equals to RPR PC BC. Am I correct? Yes?
Sir, I think the second equation that we is a V should be so VRBC.
Which one? V is
denominator. The first term.
Yeah, VR equals to V by BC, no?
No, sir, in the denominator, sir.
Yes, not many people, only one. I get confused. Who can volunteer?
Sir, the first
This one.
The
First term is what? PRPC, this one?
yeah.
27 R square PC square by 64
PC VR square BC square.
PC,
VR square BC square.
just a minute. PC VR square. Yes. Correct? Okay. This is agreeable or not? Agreeable, right? Next step. What is the term? You can actually be helpful if you write PC BC by RTC. How much is this? This is a very cube because if you can evaluate this, then you can use that term here. PC BC by RTC. Don't say just C. This has got numerical term. Because PC you can substitute by A by 27B square, BC by 3B, TC by 8A by 27BR. If you substitute, how much you get? PC BC by RTC. Don't say just C. This is a good term is that. How much it is? Substitute and tell me how much it is. That is important for this term. Because if you can calculate, we can take the reciprocal and get the answer. Because the final equation of state should not have any TC, PC, BC. PR, VR is only allowed. PR, VR, TR. If I can replace with that something, even ZC also if you do, the wrong answer because I should not have any material properties. The law of corresponding state has no sense. The law of corresponding state has no sense. So PC, BC, RTC is how much? If you just substitute all the values, I have already done last part. How much? 3 by 8? 3 by 8. Yes. What is the next term? 27 R square TC square by 64 TC square VR square BC square. Sorry, BC square. How much you are getting? 27 R square TC square by 64 PC square BC square. You have to replace these things, otherwise you cannot have equation of state in corresponding states. 27 R square. So TC square you can actually put the value. What is TC? 8A by 27 BR. PC is A by 27B. BC is 3B. If you substitute, how much you get? You get a number. You get a number. Very nice number you can get. What is that number? How much? One person got 3. 3. Wow, great. PR plus 3 by VR. Am I correct? VR minus 3. 3. Not 3. 1 by 3. Equals to. Yes. What you have to do here? You have to calculate TC by PC BC. How much you are getting? Do the same way. TC by 8 8 by 3 PR, and you can finally get PR plus 3 BR square, 3 BR minus 1, 8 PR. This is the equation of state. Now you can say this equation is dimensionless, valid for any materials. This is valid for any materials. That's very interesting part. Why? Now you can go to compressibility factor chart. Any books you take, we have the compressibility factor chart, Z versus PR. You might have seen this kind of chart. Here TR equals to 2. For different TR, the values are there. TR equals to 1.5, 1.3, 1.2 and so on. This is for immaterial. This is immaterial. In fact, this kind of graph, if you look at, if you want to draw for any materials, all materials will fall by this graph. If you say some alcohol material, water or salt or whatever, it should go by this material invariant chart. Earlier days, when I was teaching this course 2-3 years back, I used to ask my students, draw a MATLAB program to get the curve. Now you can see in the books they draw the curve. Earlier you didn't know how to draw the curve. Now you know how to draw the curve. Okay? So, if you look at, so this is the equation of state. The question is, so far we don't know how to get in terms of compressibility factor. I will finish it in 1 minute. You have to go for lunch. From this PR plus 3 BR square into 3 BR minus 1, 8 TR, it is possible to write, substitute Z equals to PD by RT, and you can get Z plus 27 PR by 64 Z PR square into 1 minus PR by 8 Z PR equals to 1. We'll prove it. We'll see who can prove in the next class. I want to see in the Monday. And if you have this kind of thing, and from here it is possible to get this diagram. And this equation how to solve by Cardinal's method. So now you can see this Z polynomial, but all the terms in terms of reduced parameter. The problem what you solved last time, that in terms of Z1, Z2, Z3, and all the alpha, beta, gamma, they are all in terms of the reduced parameter. So this equation you can solve by Cardinal's method and get the MATLAB plot and get this kind of diagram. What is available in the book. So this is the mathematical way to derive the compressibility factor chart. I think I have learned the first time in the class. Thanks for your kind attention.